Hi there, welcome to finding inverses of matrices and then using that process to solve some systems of equations. So this is leading us, this inverse matrices stuff is leading us into being able to do some application problems, and one of them will be solving systems of equations. And we all know that when you solve a system of equations, that's really applicable to a lot of different situations. So we have a couple goals today. We're going to learn how to find an inverse of a 2 by 2 matrix by hand. And then after that, anything beyond a 2 by 2, we will use our graphing calculator to find. And then we'll be able to write our matrix, our equations, systems of equations in matrix form. And then by the end of this, you're going to be able to solve a 10 by 10, meaning 10 equations and 10 variables system of equation in a matter of minutes. So before we can actually talk about the inverse, we need to take a look at what an identity matrix is once again. Just to refresh, an identity matrix is going to be a square matrix, so same number of rows as columns, and it will consist of ones on its main diagonal and zeros everywhere else. So when you're looking at your matrices, you can see the main diagonal is all ones, and then everything else will be zeros. Our multiplicative inverse is the same thing if you were solving an equation and you wanted to undo multiplying by 2. You would multiply by 1/2 because a multiplicative inverse or a pair of multiplicative inverses are two numbers that when you multiply them, you get 1. When talking about matrices, 1 is really our identity matrix. So this is the same thing as saying 1. And what we're doing here is we're taking some matrix A and we're multiplying it by its inverse. Okay, so that's like 2 and 1/2 or 2/3 and 3/2 or something of that nature. And when we multiply them, we're always going to end up with just 1. Well, in the matrix world, that 1 is our identity matrix. So I want to start by verifying that two matrices are actually inverses of each other. Now we need to do two things with each of these. We have to show what A times B is and what B times A is, because in either situation we should get the inverse, okay? I'm sorry, the identity. And then same thing here. Let's call these C and D. So we have to show that C times D and D times C both give us the identity. I'm going to have you guys do these on your calculator. I do not need you to do these by hand. So take a moment, type A, B, C, and D into your calculator, and then find the product of A times B, write that down, and find the product of B times A, write that down. Same thing with C and D. Come back and we'll talk about what you found. All right, so when using your calculator, you should find that you get these results. Now, for the first one, A and B, when you multiply them, you get the identity matrix, which is a 2 by 2 matrix in this case. And then for the second set, you got the identity matrix, which in this case is a 3 by 3 matrix. Okay, so we have now shown how we can verify that two matrices are actually inverses of each other. But what if I just gave you one matrix and I asked you to find the inverse? This can, like we said earlier, can be pretty lengthy. So we're only going to do this with a 2 by 2 matrix because there's a pretty easy formula we can follow. But the key is, in order to find an inverse for a matrix, the original matrix must be square. That is really important. If the original matrix is not square, there is no inverse for it. All right. So to find the inverse, we're going to actually set up a matrix equation and solve it. And our matrix equation will be A times X equals I. And these are all matrices, right? So A is the matrix that we're given. X is the matrix made up of variables, and I will result in our identity. So for example, we have matrix A, which is 1, 4, -1, -3. All right, and then matrix X, we're going to make also a 2 by 2 matrix. It has to be the same size. And we'll call these A, B, C, and D. And what we have to get is 1, 0, 0, 1. So our goal here is to figure out, what would we have to do here in order to get a true statement. So this is when understanding our multiplication process is going to be really important. Okay, so to multiply our two matrices by each other, 2 by 2 and a 2 by 2, we know the result will also be 2 by 2. But we know what should go in each blank. right? So let's set up our multiplication over here on the left. All right, we're going to have our 2 by 2 matrix, and I'm just going to go through the same process we've gone through before. I'm going to label them row 1, column 1, row 1, column 2, row 2, column 2, sorry, row 2, column 1, and row 2, column 2. Let's go ahead and focus on row 1, column 1 for a moment. So I know I'm going to have to take this row times this column. Okay, so I'm going to do 1 times A, let me write that a different way, 1 times A plus 4 times C. Now that seems really not very useful, right? But we're going to come back to that. Row 1, column 2 will be 1 times B plus 4 times D. Row 2, column 1 will be negative 1 times A minus 3 times C. And then row 2, column 2 will be negative 1 times B minus 3 times D. Now, here's what we know. We know that that has to result in this matrix, right? So each corresponding element has a specific number that it will be equal to. So what I can end up doing is setting up this system of equations. So what I have is 1A plus 4C must be 1. I also know that 1B plus 4D must be 0. I know negative 1A minus 3C equals 0. And I know that negative 1B minus 3D has to be 1. What I end up with is 2 systems of equations with 2 variables in each one. So this can be a little daunting, right? But now, in this particular circumstance, these are pretty easy to solve. If I'm going to focus on system number 1 here, I notice that if I add those 2 together, I'm going to eliminate A, and I get C equals 1 when I add the 2 equations together. Now that I know C, I can plug that in to find A. So I know A plus 4 times 1 equals 1. So I get A equals negative 3. So now I know what A and C are. Let's do the same thing for B and D, sorry. So this is system number 2 now. Okay, so when I, again, add those 2 equations together, I can eliminate B, and I find that D equals 1. I can plug that in to 1B plus 4 times 1 equals 0. And I'm going to get B equals negative 4. So here's what I know. This matrix up here that I said will be the inverse for my original matrix ends up looking like this. We know that A is negative 3. We know that B is negative 4. We know that C is 1. And we know that D is 1. So this is the inverse of matrix A. All right, here's what I would like you to do. I would like you to do the same thing for part B. So pause the video, set up your matrix equation, use what I kind of laid out here as a format, and see if you can figure out what the inverse is. All right, so what you should have gotten for that inverse is up here, 3, 2, 1, 1, and I have the other inverse written here. Now what I want you to do for just a second, just pause the video for a moment, and compare the two matrices, right? So look at matrix A and look at its inverse. In B and A, both. Look at matrix A here and matrix, the inverse of matrix A. See if you can find any relationships. So pause the video here, take a look at it, think about any relationships that you might see, and then we're going to talk about how to do this a lot faster. All right, so hopefully, maybe you noticed a little bit with how the original matrix, the numbers within the original matrix ended up looking in the inverse matrix. And what I hope you've noticed is that A and D, these 2 values here, just switched places. Go back up and look at the 2 sets of matrices we talked about above. C and B just changed the sign. They became exact opposites. So C became negative C, B became negative B. Now, the thing that you don't know, because in the previous 2, these are just 1, is that there is actually a scalar multiplier out in front of each of those inverse matrices. And that scalar multiplier looks like this. You take 1 divided by the product of AD minus the product of BC. Now, if you look at where those are in your matrix, that's the product of the main diagonal minus the product of the other diagonal. So for a 2 by 2 matrix, we can very quickly find our inverses. All right, so let's go ahead and talk about how we can do that here. So find the inverse of each of these matrices if they exist by hand. So I want to use the formula here. Okay, so to find the inverse, I have 2 steps. The first thing I have to do is figure out what my scalar multiplier is going to be. So I'm going to do that out in front. So 1 over a times b minus b times c, right? I take this diagonal multiplied by, or subtracting from that diagonal. So that's going to be 1 over 3 times 2 minus negative 1 times negative 2. And what I get there is 1 over 6. Okay, so that's going to be minus 2. So that's 1 over 4. That is my scalar. Okay, so then from that point on, to write my actual inverse, I have to put that scalar out in front. Now, the inverse, or the matrix itself, what's going to happen is these 2 elements just switch places. So that's 2, that's 3. And then these 2 elements end up changing the sign out in front. So it's negative 1 becomes positive 1, negative 2 becomes positive 2. That is our inverse matrix. Now, if you do this on the calculator, it's going to show you what it is when you actually multiply through by the scalar. So, you're going to do 2 times a fourth, 1 times a fourth, which I'm going to write those as fractions. You guys know I prefer fractions. So 2 times a fourth, that's 1/2. 1 times a fourth, 2 times a fourth again, and then 3 times a fourth. So this would be what your calculator would tell you, and actually it'll give it to you in decimal form, but they are equivalent to each other. Okay, why don't you try B? Pause the video, try it, and come back and check your work. So you probably got to this point in the process and you thought, well, Mrs. Kopp, this is undefined. So what happens if my scalar is undefined? Well, that just means that there is no inverse for B. So if you get an undefined value for your scalar, you can't actually find the inverse. All right, and then finally, I want you guys to try to find the inverse. So we've looked at 2 ways of finding the inverse, right? We set up that matrix equation, put the variables in A, B, C, and D for our inverse, and then solved that 2 by 2 by 2 systems of equations, right? 2 systems of 2 by 2. So that's one method. The other method was what we just did, where we have that formula. And the third method, and this will be the one that I want you to use for anything bigger than a 2 by 2 matrix, but we're going to practice with the 2 by 2 matrix here, is to use your calculator. So there's some nice kind of steps here for you to follow. I want you to go ahead and go through that. So enter the matrix A that you see here. So this 2 by 2 matrix of 4, negative 3, 7, 2. And if you need to pause the video and do that and come back. Once you've got that entered, go back to your home screen. So make sure you quit, second quit. And then go back into your matrix menu. We're going to select from the names part of the menu, right? We're going to select matrix A, the one we just entered. That'll be what you see on your home screen. And then you're going to press the X to the -1 key. That is actually the same key that you press to get your matrices. You just don't press the second key first. All right, so we press the X to the -1 key, and this is going to show up on your home screen. When you press enter, you get this. Now, some of you may get something that looks a little bit different depending on the version of the calculator that you're using, but it's going to give you some kind of grody decimals. You may have to push your right arrow to actually see these elements over here because they're not visible. If we would like to actually see the matrices in fraction form, so before you do anything else, right, don't do any other calculations, go back into your math key, and we're going to select this turn into fraction option. When you do that, it'll display your matrix like this. So we can tell from that that our scalar would have been 1 over 29. All right, so 1 over 29, and then 2, 3, negative 7, and 4. We could perform the rest of it pretty easily as a 2 by 2 matrix. But I do want us to be able to find a way to display our answers as fractions in the matrix on the calculator rather than just writing these really ugly decimals. So the key to this is that we can use our calculator to find inverse matrices for anything bigger than a 2 by 2 matrix. Because for this, we could probably do it by hand pretty quickly. But when we get to a 3 by 3 or something larger than that, imagine what we set up with this, which ended up being two systems of equations, each with two variables. This is going to end up being three systems of equations, each with three variables, and that gets really tough to solve. This would be four systems of equations with four variables, and it's, again, pretty tough to solve. So we're going to stick to the calculator for anything bigger than a 2 by 2 matrix. So what I'd like you to do, pause the video once again, just practice a little bit with this on your calculator. If you're using the online calculator, there will be an option that you can choose on there that looks like this, right? So you just select that once you've entered your matrix, and it will give you your inverse matrix. Now, I'm not sure on that if it'll convert it to a fraction or if it's going to give it to you as decimals. I haven't played around with it enough yet. You guys will have to let me know what you find. Okay, pause the video, try it, and come back and check your answers. All right, take a moment, check your answers. For A, you got an error message, and that tells you that your scalar ends up being undefined again, so there's no inverse possible. For the three other matrices, you should have been able to get some inverses. You know, if you wanted to, you could try to figure out what your scalar is and rewrite it with the scalar out in front. You don't have to, but I do want you to be able to write it as fractions. Okay, I think we're going to call it quits there for today. I'm just going to have you practice a little bit with inverses, and then we'll get to solving the systems of equations with inverses in our next lesson.